So the question is, determine the surface area of the solid obtained by revolving the curve with parametric equations. So you got two equations here. Between theta is equal to minus pi over 2 and theta is equal to pi over 2 about the x-axis. So here's your two parametric equation formulas. A, this is x, that means revolving around the x-axis. Okay, this is on page 7, 6 and 7 of the formula sheets. Now, here I have x is equal to 2 cos to the power 3. What must I do? I need to find dx d theta. So, that's going to be dx over d theta. So how do I differentiate something like this? I have an exponent, which is a number. So I use the chain rule. So that's going to be 2 times 3, which is 6 cos 3 minus 1, which is 2. So I deal with the power first, times the derivative of cos, which is going to be minus sine theta. So that is my dx over d theta. Now, y is equal to 2 sine to the power 3 theta. So here, dy d theta. So I'm differentiating again, chain rule, 2 times 3, that will be 6 sine 3 minus 1, which is 2. And the derivative of sine is going to be derivative of sine is just positive cos. The derivative of cos is minus sine. So what do I have now? I just have what's inside here. I need to square it and add it up. Okay. So dx over d theta plus dy over d theta. So I'm going to square there and square there. That's what I want to do because I'm working out what's on the inside. So that means I got 6 cos squared theta times minus sine theta there. 6 sine squared theta cos theta. And what am I doing? I need to square that and I need to square that. There's my square and square that. You see that? Simplification here is very important. Now, exponent laws. When you are squaring something, so if I got a times b times c, all raised to the power n. Okay, so this can be written as a to the power n times b to the power n times c to the power. Apply your exponent law. That means if it's multiplication, every single multiple, every single factor will be affected by the power. So this is 6 squared, which is 36. Cos squared all squared is cos to the power 4. When you have a power raised to a higher power, multiply the exponents. Negative squared is positive, sine squared, so that's a sine squared. Alright, 6 squared here is 36 sine squared, all squared will be sine to the power 4, and this is going to be cos squared. Now, if you take this and substitute it here, you're going to get stuck. Because how do you integrate something like this with the square root there? Right, it cannot be integrated. So what must you do? You need to simplify further. Okay, you need to simplify as far as possible. Remember, this is the last question in the exam. So it will not be easy. Everything needs simplification before substituting. So now, notice that there's a common factor of 36. There's a common factor of sine squared. And there's a common factor of cos squared. Can you see that? So that's going to be 36 cos squared times sine squared. So now I took out my common common factor. What am I left with inside here? If I took out 36 cos squared sine squared, that means I'm left with cos squared here, am I right? Because cos squared times cos squared is cos to the power 4. Plus, what am I left with here? Sine squared. Now, this is equal to 36 cos squared theta sine squared theta. This is your square identity now. Cos squared plus sine squared is equal to 1. So that's as far as we can go. Alright, so now let's write down the formula and then substitute. So we are rotating about the x-axis, so that's going to be 2 pi. That's your theta 2, theta 1, that's y, and that's dx d theta all squared dy d theta all squared d theta. Right, that is the formula. I'm transferring it here. It's just that the 2 pi is a constant. That's why I'm writing the 2 pi in front there. So this is equal to 2 pi. I've got my theta 2, theta 1. What is my theta 2? What is my theta 1? Theta 2, where is it? It's here. Okay, so this is, let's call this theta 1, theta 2. So we're going from the negative in the bottom, positive to the top. What is y? What is y? That's a y. So we'll go to y. Y is equal to 2 sine to the power 3. That's going to be 2 sine to the power 3 theta times the square root of this we worked out here now. Can you see that? Which is 36 cos squared theta sine squared theta. Okay. So now we need to simplify and then we need to integrate. So let me give you 2 minutes to just try and absorb what happened. Alright, so now this can be simplified further. So I got this 2 pi times the 2 here, which will be, well, let me just leave it as it is for now, not to confuse you. So that's my pi over 2 minus pi over 2, that's 2 sine to the power 3. Now, the square root of 36. So basically what's happening here is the square root of 36 times the square root of cos squared times the square root of, okay, so that's going to be 6 times. Now I explained to you yesterday the square root of cos squared is the absolute value of cos, and the square root of sine squared is the absolute value of sine. But you won't get this, that's not the proper way to do it, but let's just do it the way it's done in your N6 program. So the square root of cos squared, we're only taking the positive here. So that will be cos theta and sine theta. So they're both positive, because sine and cos are both positive from minus pi over 2 to pi over 2. Right, that's trigonometry. Now, let's deal with the actual integration. So it's simplified. Now, what can we do? Here we have 2 pi. Okay, that's 2 times 2 times 6. So 2 times 2 is 4. Times 6 is equal to 24 pi. This is my pi over 2 and minus pi over 2. What do I have here now? Sine to the power 3 times sine is going to be sine to the power 4. Now clear, right? Times my cos theta d theta. So now, here, this is multiplication, exact derivative. The derivative of sine theta is cos theta. So I've got sine theta to the power 4. This is, I can write it like in brackets, sine theta all raised to the power 4. Same thing. So now these are exact derivatives. Remember, what do we have here? We have f to the power n, the integral, times f prime with respect to x. So you got f prime. So you know the formula is going to be n plus 1 over n plus 1. So that's going to equal to 24 pi. And this will be sine theta to the power 4 plus 1, which is 5 all over 5. The derivative of sine is cos. This is a 100% exact derivative. I don't need to go and manipulate anything. You can see that. You do not have time when you come to this step to let u equal to, but you can. If you're answering this before question 5, you can use your u substitution, let u equal to sine, you cancel, but basically you have to know your integration properly. And you have to do it fast. So this is pi over 2 minus pi over 2. So what am I going to do now? Let me just take out this 1 over 5 to make it easier for substitution. So that's 24 over 5 pi, and then I got sine theta to the power 5. So you can remove the constant before actually substituting. Alright, but it's up to you. If you're not comfortable with doing this, then you do it how you always do, by leaving it there. So I need to substitute now. So that's 24 over 5 pi. This is going to be sine of pi over 2 to the power 5 minus sine of minus pi over 2 to the power 5. So I'm substituting pi over 2 and minus pi over 2. Calculator in radians here. Be careful. Calculator in radians. So now that's 24 over 5 pi. And now this is, well, if I'm using, you can do it in radians here. I know this is going to be 1 to the power 5, which is 1. This is going to be minus 1 to the power 5, which is going to be minus 1. So 1 plus 1 will give me 2. So that's going to be 24 times 2 is going to be 48 over 5 pi. Work that out for me. 48 over 5 times pi. What do we get?
30,139.
Read that.
30,139.
159. So that's going to be units squared, because this is area. So area will be squares. And that is the first one. Let's deal with the next one. Right, so let's deal with the next one. We got parametric equations again. X is equal to t squared over 2 plus t. Y is equal to t plus 1. Let's differentiate and substitute. So here, I can find, okay, let me just write that down. X is equal to 1 over 2 t squared plus 1. So dx over dt, the derivative of half t squared plus 1, half times 2 is 1, so that's just t plus 0. Are you clear with that? Right, so here we got y is equal to t plus 1. Sorry, my mistake. That's plus t, my mistake there. That's half t squared plus t. So that's going to be t plus 1. Okay. So then here, dy over dt, the derivative of t is 1 and the 0. Right. Now, we have dx over dt all squared plus dy over dt all squared. Right, so now we squared and add up. So this is going to equal to t plus 1 all squared plus 1 squared. That's what we have there. Okay, t plus 1 all squared plus 1 squared. Let's square it and see what happens and then substitute. So t plus 1 all squared, so that's going to be t squared plus 2t plus 1. You know when you square a plus b, and this is going to be plus 1 squared, which is 1 again. We're clear with that? So this becomes t squared plus 2t plus 2. That's all I can do there. Now, let's substitute. So we're revolving around the x-axis again. So that's going to be 2 pi, and that's going to be a y there. And that's the square root of, that's going to be dx over dt squared plus dy over dt squared dt. We're integrating, we're substituting our t2, t1. We call it theta 2, theta 1, it's just that it's t. So now, let's substitute. That's going to be 2 pi, t2, and t1, that's going to be 2 and 1. What is y? What is y? Y is equal to t plus 1. Okay, y is equal to t plus 1. And this whole thing is multiplied by the square root of t squared plus 2t plus 2. So that's t squared plus 2t plus 2 dt. Okay, now how are we going to integrate this? How did we integrate the previous example? Check. What do you notice here? This is t squared plus 2t plus 2. When you differentiate t squared, you get 2t. When you differentiate 2t, you get 2. This is not 2t plus 2, but it can be manipulated. Now, I'm going to be using alright, so now here you must recognize that is it possible to do it by inspection? Use substitution. If that doesn't work, then maybe it's integration by parts. But let's see now. So I've got f of x, so in this case f of t. So that's, let me show you. That's 2 pi, and I got my 2 and 1. That is t squared plus 2t plus 2, all raised to the power half. Okay, and there's my dt. Now, what is the derivative of t squared? The derivative of t squared is 2t, and the derivative of plus 2t is plus 2. Now, what was this? There's no 2t here, it's just t. There's no 2 here. So, let me show you now. So, 2t plus 2. This is what I have. If I multiply it by half, so half times 2t is t, and half times 2 is 1. It comes back to the same thing. That is integration by inspection. Okay, so I'll multiply by half, and now it's a 100% exact derivative. Okay, I mean it will, if I have to multiply this, you get back to what it was. But now if you're not familiar with this, then you use substitution. Okay, so now that's going going to be pi, and that's going to be t squared plus 2t plus 2, and then half plus 1. That's going to be 3 over 2 all divided by 3 over 2. This half multiplied by the 2, it cancelled, it gave you 1. So we are ready to substitute 2 and 1. You can use changing the limits if you want to, but let's just do it as it is. So that's going to be pi, and that's my 2 over 3 there. That's t squared plus 2t plus 2 to the power 3 over 2, and that's my 2 and 1. Give me the calculator, let's see what we get. Let me this calculator, So what do we get here? Let's see. So we'll substitute 2 first, and I get 21.08185.107. Then I will substitute 1. I get 7,453559925. Are you getting the same thing? So if I substitute 2, I get that minus 7,453559925. I get 13,628291114 multiplied by pi. So I'm getting 42,814539334, which is equal to 42,815 units to the power 2. Is that the correct final answer? Check this. 42,815. Remember here, if you're not familiar with inspection, then you could let u. So remember this part here, you can let it equal to u, find du over dt, if you got time for that in the exam. Okay. Oh, the mistake here, sorry, there was a mistake. The question was a 2 and 0. So that's a 0, 0, 0. That's 0. So this will come out, and if I put a 0, let's see what we get there. Give me the calculator. Got it? Yeah, that was substituted 2, that's what I get. Substitute 0, that's 2 over 3, and that's 2 to the power 3 over 2. 1.885618083. So that's 21,0818510 minus 1.885618083. It's going to be 19.196232299 times pi, which is 60,307 units squared. Right, so there's no problem with the integration. The problem was I copied down 1 instead of 0. next question. So our next question here is determine the surface area generated when, I didn't write down the whole thing, but the main point is you got the graph y is equal to x cubed rotating about the x-axis. Alright. So what is the formula that we need to use? This is not parametric equations. So this is, let me just write this down. You are rotating about the x-axis, so it's going to be 2 pi y, and that's going to be 1 plus dy over dx, all squared dx, that's your b and a. If you compare to the arc length formula, for arc length, the only thing, what's extra here is the 2 pi y. Right. So this is for surface area, the other one is for arc length. What do we need to do? We need to find dy over dx. We need to square it. So now, y is equal to x cubed. So if I differentiate this, dy over dx, the derivative of x to the power 3 will be 3x squared. What do I need to do now? I need to square it, I need to add 1. So now, I'm going to go 1 plus dy over dx, all squared. And what is my dy over dx? My dy over dx is 3x squared. Right. So the 1 plus dy over dx all squared. So this is going to equal to 1 plus 3x squared all squared. This is multiplication. So 3 squared will give you 9. X squared all squared will give you x to the power 4. Now it is ready for substitution. So now I got my a, x, this is rotating or revolving around the x-axis, is equal to 2 pi y. What is y? Y is equal to x to the power 3 times the square root of, what did we just work out now? We worked it out, it was 1 plus 9x to the power 4, and that's integrating with respect to x. B and a, we are given from 1 to 3. So just double check if I copied down those values. Right, so that's 1 and 3. And now, again, we come across the same type of integration. This is exact derivatives here. Okay. So this is exact derivative because that's an x to the power 4, this is an x to the power 3. Similar to the one that I just did. So this is equal to 2 pi, here's my 3, 1 there. So I've got my 1 plus 9x to the power 4 all raised to the power half multiplied by x cubed dx. Now you can see it much more clearly. This is my f of x. This is f prime x. The derivative of 9 of x to the power 4. 9 times 4 is what? 36. So if I put a 36 there, I must divide by 36 because 36 and 36 will cancel. It will give me my y. That is integration by inspection. So this becomes 1 over 18 pi, and this is going to be f of x, 1 plus 9x to the power 4, half plus 1 then, which is going to equal to 3 over 2, all divided by 3 over 2, substituting 3 and 1. Okay, this is integration by inspection. If you want to try your substitution, you can, but very few people will have actual time in the exam to go and use substitution. Yeah, but it is still correct. If you've got time, you do it. You'll let you equal to 1 plus 9x to the power 4. Right. And now this becomes 1 over 18 pi, and that's 2 over 3, and that's 1 plus 9x to the power 4 to the power 3 over 2, substituting 3 and 1. Calculator? Oh, but who's not using the calculator? So let's work this one out. That's 2 over 3. 1 plus 9x to the power 4, all raised to the power 2 over 3, so 3 over 2. Substituting 3 first, I get 9.00926 minus, substituting 1, I get 21.08185107. Now I'm getting 1327.92741, and that's multiplied by pi over 18. I'm getting 2291.2555572. Correct? So that's going to be 2291,256, rounded up to 3 decimal places. Is that the correct answer? So now, let's move on to the next one. Alright, so let me start with this one. So find the surface area generated by revolving the curve. Y is equal to the square root of 1 minus x squared from 0 to 1 over 4. Similar to the previous one about the x-axis. Right, so now let's see what we have here. We got y is equal to the square root of 1 minus x squared, which is equal to 1 minus x squared to the exponent or to the power half. Right. Now we need to differentiate this. So dy over dx. We have to use a chain rule because we have a power which is a number and the base is in terms of x. You can see that. So that's going to be half times 1 minus x squared. Half minus 1 is minus half times the derivative of 1 is 0. The derivative of minus x squared is minus 2x. Now, this is not an easy example. Right? So simplification here, very important. We don't leave it like this here. Right, so here 2 and 2 will cancel. This negative power, I'm going to take the base to the bottom. So it becomes 1 minus x squared to the power half. 2 and 2 cancel, I end up with just minus x in the numerator. Can you see that? Just minus x because just 2 and 2 cancel. The base, 1 minus x squared, you take it to the bottom. Right. So this is basically equal to minus x all divided by the square root of 1 minus x squared. Right, now we're going to go 1 plus dy over dx all squared. Let's let's see what happens when we square. So we got our minus x all divided by the square root of 1 minus x squared all squared. You can see that? So now that's going to be 1 plus, you square that, negative x all squared is a positive x squared. The square root of 1 minus x squared all squared is just 1 minus x squared. Alright, it does not end there. There are two terms. Find the LCD. So your LCD is going to be 1 minus x squared. That means this is multiplied by 1 minus x squared, and then I got my plus x squared. Okay, that's an LCD of 1 minus x squared. Now, if you're confused, basically what happened there is I got 1 minus x squared over 1 minus x squared plus x squared over 1 minus x squared. That divided by that is 1. There's a chair, you can see that. Once your denominator is common, you write it down once, and then you deal with the top. Right, just that I'm doing it in one, I'm skipping steps. Alright. So now, minus x squared plus x squared is out, so I've got 1 over 1 minus x squared. That's as far as we can go. Now, let's substitute into the formula. So now, we're going to substitute. So, I have B and A, 1 over 4 and 0. So your A and B, 0, 1 over 4. Okay. Times, this is 2 pi. What is y? Y is the square root of 1 minus x squared. Times the square root, which is this part here, of what we just worked out now, which is 1 over 1 minus x squared dx. Follow what happened then? All I did was substitute. So now that's going to be 2 pi 1 over 4 and 0. We got the square root of 1 minus x squared. Now we got the square root of a fraction. The square root of the numerator divided by the square root of the denominator. The square root of the numerator divided by the square root of the denominator. Exponent belongs here. That and that cancel. So I'm left with just the square root of 1, which is 1. So now all I have to do is just integrate 1, and then I'm done. So this is equal to 2 pi, integrate 1, that's x, substituting 1 over 4 and 0. That's all. So I got 2 pi, basically I'm going 1 over 4 minus 0, 2 pi, that's 2 over 4 pi, which is equal to pi over 2, which is equal to 1.71 units squared. So the difficulty here was not the integration, it was getting to that part. But this is still not the most difficult example. There are more difficult examples than this. But we end there for now.